Alright, I think I've done as much as I can with these sockets, and now it's time to move on to this board. That's where these resistors attach. They're just floating in free space. Attach one end to the tube socket, other end goes onto this board. I've got tube filaments wired up. One of them going to ground, and the other one going to this pin and over to here, and then these two go off into the rest. Or again, as I said, one side of the filament is actually ground. It's just a chassis point, tie point, and then the other filament wire will run through. Alright, so I cleaned up this board. One of the lugs was already broken off. We'll do what we can with that. I can just stick the leads down into that hole and fill it up with solder, and it'll be fine. Yeah, I went through the parts list, because all you get for the identifier on this parts locator is the number, so I went through and picked out all those numbers and wrote down what the component values are. As far as the parts that were on there, I think I'll reuse a couple of them. There are power resistors at one end, a 13K and a 15K. The parts list specs out 2 watt and 1 watt. I think these are both actually 3 watts, or at least 2 watts, so that'll be fine. And actually, these are all 2 watt resistors as well. They're just in small packages. That's because with modern materials, you can pack a higher wattage resistor into a smaller package. In other words, the material these are made out of can take the heat. But they are actually all 2 watt resistors. I bought up a whole bunch of these, the 2 watt and the 1 watt size, because I really like these. I'm made by Vichy, because they look kind of like carbon comp, even though they're actually metal film resistors and flame proof and very stable, all that good stuff. And it's easy to read the color codes on them. Now, as far as the values go, if you look on the parts list, you'll actually find some oddball values like 40K or 99K. Well, I rounded those off to the closest modern values. Sometime back in the 40s or 50s, they came up with a new standardized scheme for resistor and capacitor values, and it actually makes sense. If you want to know more about that, look up the history of component values, but it has to do with kind of like doubling the value, like 1K, and then 2.2K, and then, well, it actually has to do more with the tolerance, so I think it goes 1K, 1.2K, 1.5K, 1.8K, 2.2K, and so on. When you go plus minus 10%, it covers the span on either side, and you go jump up to the next value. Whereas back in the day, it was kind of a free-for-all, using whatever values they want. Like why they would use 99K instead of 100K when 100 is a nice round value, I don't know, but they did. So anyways, that's that. And then the same for the capacitors. Like instead of 0.02 these days, we have 0.022. So we've got all new capacitors ready to go in. So I will attach them to this board, and then I will attach the board in here and then hook it up as indicated. Now they don't show all the wiring on here. So it's a great guide for component placement, and some of the resistors they show where they wire up. For example, on this board, they do not show where all the other wires go to, like say this capacitor or this end, this lug. There's nothing going to it. So I have to do a little bit of guesswork. Like for instance, this power resistor, one side goes to a filter cap. It is this guy right here. So one side goes to this stuff, one side goes to that stuff. I don't know which end is which. But I do know that one end goes to the 15K, which is right here. So originally 2 of these were shorted together. Maybe I can look at the photos and tell which. Otherwise, I'll just do whatever seems to make the most sense. So for example, this mounts in like that. Filter caps are over here, so it seemed to make sense to me to have this lug go over to the filter cap close to it for the shortest run, and then these two would tie together as the common point. I'm going to attempt to open up this filter capacitor by cutting it right along this seam here with a sharp Stanley box cutter. Brand new, very sharp blade in there. Go right at that seam, right below the lip there. And the reason I do it like this is it makes a really clean, sharp cut. together, you never know anything could happen. This aluminum's soft and fairly thin. There, I'm already in. Let's walk it around. I notice there's no liquid coming out. This thing dried out long ago. I think the culprit is down here. Quite often you'll see a lot of crystals around here and corrosion. It's electrolyte leaking out. Either that or the seam up here allows air to get in and it dries out. Electrolyte, I believe, was boric acid. Only once, I think, did I find liquid still in one of these. A little bit left to go. That center post out. That's it. That's what was in there. So this would be the anode. And the cathode was the outer can and the electrolyte itself. So don't need that. And just leave the insulating mesh inside there. It's not going to hurt anything. And so I'll rinse it out with some water first, but it's pretty darn clean. And simply take my new electrolytic. I'm going to look up to see what was originally in there. So it's this guy, I think. Yeah, 66A and 66. That's the other guy. It's a 2-section. Whereas this is a single 12. So 12 is kind of an oddball value. Could go with 10. Which is probably what I'll do. You don't want to go too high, like I'd use a 22. Not on that first cap, because that's right off the rectifier. And if you put too big a filter cap there, you stress the rectifier and you get like arc over on the plates when you power the radio up. Not a problem to increase this, like originally it was 8. To put a 10 or a 16 there, no problem, because the field coil has a fairly large resistance and it's going to soften the blow, so to speak, on the rectifier tube, but not this guy. It's right on it. And it acts like a dead short when you turn the radio on. 16 would probably be okay, but I don't think I have any on hand. That's also going to be the highest voltage cap, so I'll use something sufficiently rated. And as typical of these caps, there's no markings on it indicating the voltage or capacitance. Let's see, let's show the voltage. Usually they don't have the voltage on these things. Electrolytic condenser. How useful. Not even a value. It's just an electrolytic condenser. Alright, well, one indication of what the voltage might be on it is on the service info. The voltage chart here. They don't show it on the rectifier, but if you look around here, actually no, they do show it on this 325. when the radio is operating across that cap. So 450, that should be enough overhead. When you power it up, the voltage will be a bit higher, but I think 450 will be okay. So, what to use? Well, I know I've got some 10 at 450, or 10 at 500. There's an 18. I think I'll just go with 10. And then I'll put the capacitor, I'll make the capacitor on the other side of that field coil a little bit larger. So originally it was 8. Maybe I'll go with the 18 or 16 or 22 or something like that on the other side. Should work out fine. I filed away a little bit of that stuff in the end here to make room for the 2 wires, which I attached to the new electrolytic, put some heat shrink tubing around it, and with a Panasonic 10 megafarad 450 volt rated for 105 degrees C, long life, high quality electrolytic. And just pull those wires down and it's sit down in there real nice. And put the clamp back on it and remount it. It goes right in this hole here, and the negative will attach to that bias resistor, which I will need to mount soon, so it will connect to one lug on this, and it will also attach over to this board as well as does the positive. So I made sure that the wires leads are plenty long enough to make it over where they need to go. And one advantage of having this method is if you ever need to get down in there, it'd be pretty easy to snip off these leads, pop the cap out, and replace it. As far as retaching, as I mentioned, you could put a little dab of 2-part epoxy around there, pop it on, or if you can get a cork or some other styrofoam or something, glue it inside here, and you get a nice friction fit. Pop that back on there. That's another way to do it. Here's the board with new components attached. As near as I can make out, this is where these 2 resistors join. So we get the B plus comes in here, goes through this resistor, jumper over through this resistor, then through this resistor, and then this point will get grounded. That's a key element in the power supply. It's not so obvious on the schematic here, but that forms a voltage divider off B plus, and it's tapped off various points for the circuitry. So between the power resistor and the tap and these taps, that provides all the voltages for the radio. So what I think I will do is go ahead and get that other capacitor rebuilt and mounted, and then wire this in along with the rebuilt Bakelite block, and wire in just those components. Just get the power supply, the filter caps, the bias resistor, and this bleeder resistor network, and then power this up and make sure that the power supply is all squared away, and then resume the rest of it. I've made some progress wiring up the power supply. Got the bias resistor installed, and I found that putting an 820 ohm resistor in parallel with a 250 ohm resistor knocks this right down to about 190, pretty close to 187. And I adjusted this tap for 25 ohms from ground. Rebuilt this Bakelite block with the correct type of safety cap and installed that. Got one of the rectifier capacitors installed, and I put this board in. Now I've encountered a couple issues already. One is this capacitor here, 61, the guy on the end. This end does not attach to that lug. It's kind of hard to interpret these lines on here, but what they're really trying to indicate is that this end should go to this tube socket and not to that lug. I've figured that out because resistor 51, they do show go into that lug, but R51 isn't attached to R61. And what does R51 attach to? Actually, a capacitor over here, I believe 70. 44 rather. 70K here goes to 44. It's a little hard to read, but that's 0.02 microfarad cap right there. Well, where's the 0.02 microfarad cap? It's over here. So, turn this around. It's over here. So how does a resistor that attaches to this lug tie over to here? Well, looking back at my original reference phones, I saw that there's a jumper wire that goes from this lug over to here. And this capacitor should not be going to this lug, it should be going directly down to this tube. So I need to undo this lead. I'm going to take this capacitor out entirely and get an unused one that has much longer lead so I can span the whole distance here, attach this resistor, and then install a jumper wire. And there's one other jumper wire I got to refer back to the photos to see where that goes. Also been pretty careful about grounds. Like this point here is ground. So I made sure to attach a nice thick wire, and that's going to bond right down to this tie point on the chassis. It's riveted down in there. And that's also where I grounded this resistor. I'm trying to use that kind of as a common tie point for key grounds. See a rivet on the other side over here. That's how the original was done too. Yeah, I want to make sure everything gets well grounded. Now the other issue has to do with this other filter capacitor. It should be in here. And it's a little confusing on the schematic. They show a capacitor 66 and then a 66A. And on the parts list for 66, it has a very descriptive electrolytic condenser. No values given, but the part number is 302045. Well, this is what I found installed there, and that is not a 302045. Also, the values on this 20 microfarad and 10 microfarad, not 10 and 8 as shown on the schematic. Another confusing thing. Typically, the can on these is common negative, and this has two terminals coming out of it. Curious that one of them has green on there, but they don't indicate that I can see on here which section is which. Not that it really matters, but I wonder how you would have told back then. At any rate, but look on the schematic. 10 microfarad has a ground and a positive that goes here. The 8 microfarad, the negative does not go to ground. It goes to the positive on the 10, and then it's got a positive coming out. So the can cannot be a common negative to those two caps, because the negative on the two caps are not connected together. So would the can originally be the negative for the 8 and the positive for the 10? And then out of these two terminals, one is actually the negative for the 10 and the positive for the 8? That's my best guess, although so this isn't even the original correct part number. And it can't be the other can, because that's only a single cap. And part number on that, 32118. Let's see if that's right. It should be this guy, 16, 32118, 16 microfarad single section. So this one's correct. So I'm going to ignore the part number that's on here, 302163, and I'm going to wire it up and ignore that there was a 20 in here, and I'm going to wire it up the way I just described. Well, actually, I'll drill a hole for a third wire. And that's internally I will connect the negative on the 8 and the positive on the 10. And remember, I used the 10 for the 12, and for the 8 I'm going to use something larger. I'll see what I've got on hand. Maybe a 15 or an 18, yeah, even 22. I might go that high. That's all I can dig up. And I definitely have a 10 on hand I can use for that. Once I get that installed, run a few more wires. This needs to go to the power switch, hook up a line cord, and then I should be able to turn this on and check that the rectifier and the filter caps are doing their thing, and I should be able to check voltages at various points on the bleeder resistor and the bias resistor. Now they don't indicate all those voltages on the schematic, but some of them are here. Not on the schematic, but on the tube voltage deal here, because some of those taps go directly to tubes. I used to think they do. No, maybe not underneath the tubes on this chassis. I guess none of this. I've got my 3 holes drilled in the capacitor bottom, and I was thinking more about this, looking at the schematic, and I realized that they're throwing me off by showing the symbols on the capacitors as if this small bar is always the positive and the U thing is negative, because in actuality this point is negative with respect to ground. So on this one, the positive is going to ground and the negative is going to this terminal, which means the can is common negative, and this positive is going to ground and this positive is going up here. So definitely something that could easily trip a person up, since they don't show polarity on these things. I know I said I was just going to wire up the power supply and do a test, but I went ahead and wired in the audio output tubes as well, which will give us a chance to test not only the power supply, but actually try to run some audio through this and hear it out of the speaker. So I don't have the original speaker and output transformer and field coil, so what I did is tacked in a 750 ohm power resistor to simulate the field coil, and took a universal Hammond audio output transformer, a 125D, and wired it in. So red is center tap, which goes to B+, and the other two go to the plates on either of the 6 F6 tubes. And for the secondary, I've got a 4 ohm permanent magnet speaker, and I can clip that into lugs 4 and 6, which is correct. Which are the correct lugs to use for an 8 ohm impedance speaker for this transformer. And I have a chart online that shows how to select which lugs to use. So 4 and 6. And if I'm interpreting the schematic correctly, I can feed in some audio right at this point, which is a plate of the 6Q7. Seems to me that's the only path for an audio signal to get into all this stuff. So we'll give that a try. And I want to monitor the voltages. Let's just do the main B+ right here. Alright, that just leaves this leaves, I gotta rig in a little bit of audio. I'll use WaveTech 183 function generator. It's the lowest output level. Work my way up. That will be fed in right here. So just gotta plug the 183 in. And I hooked up a temporary power cord, so no power switch, is just directly going to a line cord. I'll use the power switch on my PR57. Oh, and I gotta pop in some tubes. That would help. So, 183 plugged in and powered on. Dialing in, I don't know, around 400 hertz. And tubes. So, need a rectifier tube. messy here. Keep all my wires straight. And a couple 6F6s. That's what they look like, or at least the style, the GT style. And should have one somewhere. Yep. This one's like a blackened glass, so you can't see the internal structure of it, but doesn't really matter. Alright, so that is that. Without further ado, put this thing in, and let's see what happens. Should have, I think, around 250 volts. Yeah. Just drop as the tubes warm up. Now the rest of the tubes aren't going to be in here to ooh. There's hum out of the speaker. Hey, how about that? Cool. Excellent. Excellent. Let's actually drop down quite a bit. I'm only putting 110 volts into this thing. Crank it up a bit. So I'm a little surprised it's lower. I would have thought that maybe it'd be higher than expected because I don't have all the rest of the radio to draw the current down. But using a power resistor isn't exactly the same as using field coil. It's getting pretty toasty too. Alright, well, I guess that would be successful. I was especially curious to try out the audio amp because I found this rather confusing on the schematic here. I thought there might be a phase inverter tube to drive one grid versus the other. But hey, it seems to be working right, so that's good enough for me.